Hello everyone, I'm Bozhidar Stevanoski, and I'll be presenting our work on fast automated discovery of privacy attacks against query-based systems. So first, what are query-based systems? So query-based systems, or QBSs, are one of the key approaches to safely sharing data. So consider the following made-up dataset about employees at Imperial. A QBS is an interactive interface that allows the data curator to maintain access to the dataset and allows analysts to ask queries about the dataset and retrieve aggregate answers about it. For example, an analyst can ask how many employees are at the Department of Computing, and they will receive an answer of, say, 148. So query-based systems have been widely used in practice. For example, Uber has used QBS to share data about traffic congestion on the roads. Strava has used QBS to share data about cycling and running routes, and NHS has used QBS to share healthcare data. So query-based systems, QBSs, share aggregate information about the dataset. But aggregation alone has long been known not to be privacy-preserving. These non-privacy-preserving properties have been amplified in this case because the analyst has the freedom to choose the aggregates themselves. And they can ask queries highly specific to an individual. For example, an analyst can ask the following two queries: number of employees at computing that have a salary of 50K, and numbers of employees at computing with salary of 50K, but not named Bozhidar. And assuming that Bozhidar, which is a pretty unique name, is the only person in computing with that name, the difference of one in the aggregate answers reveals Bozhidar's salary. So because of this, defenses have been implemented to protect the privacy of the people in the dataset. But before deploying the defenses, they need to be evaluated using privacy attacks. So we proposed a method, a tool, to fast and automatically discover those privacy attacks against query-based systems. So the goal of the method is finding a multi-set of queries whose answers can be combined together to infer sensitive information about the protected dataset. But even within a really simple query syntax, there are many possible sets of queries. So that means many possible attacks. So how do you search for attacks among this huge space? So we propose a method that does iterative search. Basically, it uses fast, locally informed iterations, and which show that it is able to find stronger attacks than previous state-of-the-art while being 18 times faster. That's because of the locally informed iterations. And our method is able to perform 450 iterations, while the state-of-the-art is still at iteration 1. We show that the QueryCheetah, our tool, allows automated and thorough evaluation of privacy risks, including on more users and on larger syntaxes. This is work published at CCS last year, 2024, and was awarded the Distinguished Paper Award, which I'm really happy about, to be honest. And a lot of effort and time went into the work. So if you have any questions, I'm more than happy to discuss offline. Thank you.